Hi friends, my name is Narasimha and I'm studying my BTech in Institute of Aeronautical Engineering College. Today, as a part of my AIT Tech Talk videos, the subject of computer networks, I want to explain about a topic named analysis of malware application based on massive network traffic. So first of all, about my subject, computer networks, in everywhere while we are using a web page, or while we are sending an email, while we are sending an IP address, or while we are connecting to any computer or any world wide web or in a web page, these computer networks are very useful way in which the image getting passed between two IP address or two MAC addresses. So in this video, I want to explain about analysis of malware application based on massive network traffic. So, introduction. With a widespread use of smartphones, attacks on smartphones and networks are increasing at an alarming rate nowadays. Xcode Ghost is a new iOS, means operating system malware. Several methods have been proposed to study the threat of Xcode Ghost. Next, these methods can be categorized into two types. The first type is analyze the source code of Xcode Ghost in detail to find out how the malware steal user related information, what is the leaked information, the potential threat. Nowadays, while we're coming to the smartphone side, when we are opening a web page or any web app or any page has been clicked in our phone, virus is getting installed and the malware getting installed in our phone, and the phone is losing out of control of us, and the information is getting leaked or getting lack of security for that information, and our personal details have been leaked to others mobile. So in this way, this Xcode Ghost is a new iOS malware. Next, the second type is to identify the infected applications via scanning the source code of IP4 application package. However, both of these methods provide no direct evidence to testify that the infected applications had devalued users' privacy. Besides, there are still many unsolved problems about Xcode Ghost. For example, the ratio of infected devices, the time and the traffic volume characteristics of Xcode Ghost related HTTP, this hypertext transfer protocol requests, and the infected applications. To solve the problems mentioned above, we analyzed 232 days of real network traffic developed from passive packet level monitoring of more than 2.59 million iPhone users from a provisional mobile network. So this Xcode Ghost is an iOS malware which can be analyzed in two types. First type is analyze the source code of Xcode in detail, where the actual malware detection has been done. And in second way, it will be via scanning the source code of an IPA. So for viewing this type of new iOS malware, 232 days of real network traffic has been analyzed, and more than 2.59 million iPhone users provisional mobile network has been accessed to get this type of new iOS malware. Next, related information to it. As a communication tool, smartphone has become an indispensable part of our life. The number of smartphone users has rapidly increased over the past few years. In 2015, global smartphone shipments reached 1.4 billion, 4.5 times to PCs, and the ratio between the smartphones and the PCs will persist until 2017. In China, about 594 million users surf on the internet via smartphone in 2015. The first known smartphone malware was discovered in June 2004, named Kabir, in the Symbian OS, which was propagated via Bluetooth. This is the first known smartphone malware. Once have a look. That is Kabir in the Symbian OS. Next, protecting smart devices from malware attacks is a hot topic in literature. Several reviews have been presented in works. In total, there are two research orientations to identify malicious software: static and dynamic analysis. Static means it is a finite number of analysis, whereas in dynamic it is a flowing analysis, means automatically the analysis can be done. Here is a network architecture with TMS, where we can say BTS, BSC, RNC, Node B, and uploader, TP, TMS, how it is connected to interconnected, and HDPS, SGSN, GSN, and IP network. Next, network environment and datasets. The conceptual diagram of the network structure is shown in figure 1, which I have shown before, which is network structure or architecture with TMS. Most subscribers of this network are mobile users. The high performance traffic monitoring system devices are deployed between SGSN and GGSN. They passively capture all HTTP, means hypertext transfer protocol, requests and responses between clients and servers. When we are browsing on web, World Wide Web, any website, then the connection between the clients and servers are done by the HTTP requests, HTTP protocols, and it is done by most of this network are being accessed by mobile users. These collected data are stored on a log server as records and uploaded to the head of distributed file system HDPS after removing the user related privacy. Ratio of the infected device. The developer of Xcode Ghost created a new infection vector for malware by modifying the developing tool Xcode. In this part, we are interested in the spread ability of the new infection vector, and we measure it by computing the ratio of infected device. The rule to determine whether a device is infected or not is that the device is infected if the monitored software from the device include any of the infected applications. The ratio of the infected devices and the model of infected devices are and the dynamics of Xcode Ghost servers will be explained in next further slides. So once have a look at this slide, this is about ratio of the infected device. So in the second point, we know this, the rule to determine whether a device, means if a smartphone is infected or not, is that the device is infected if the monitored software from the device include any infected applications, means the monitored software is include any virus or malware, anything. Next, these are two images ratio of infected devices, model of the infected device. And here we can see the time of day on x-axis and infected device ratio on the y-axis. Once I have a look at it, here we can see the cumulative ratio and day ratio in the ratio of infected devices and RD residential day ratio in the model of infected ratio. Next, dynamics of Xcode Ghost servers. Xcode Ghost servers can control the infected iPhones via internet. Therefore, it is helpful to understand Xcode Ghost by analyzing the behaviors of the corresponding servers. Let's have a look at this. Next, access time characteristic. Though the Xcode Ghost has been around at least 7 months ago, we didn't discover it until 1 month ago. Therefore, we are interested in finding if the Xcode Ghost related traffic is sent in the time when people are at sleep. The distribution of HTTP access time can tell us directly. This is a request distribution over a day period. Let's have a look. Request distribution over a day period. HTTP a week and 1 month, and all HTTP at 1 month. Next, application identification algorithm. Our algorithm consists of 5 steps: extracting fingerprints, getting web knowledge, data fusion, application identification, checking manually. So this algorithm, which is being processed in the network traffic, this consists of 5 steps. That is, extracting the fingerprints is the first step, and getting the web knowledge of website is the second step. Data fusion means the merging of data is third step. Application identification and means where the field which is used is the fourth step. And checking manually means now how to know is in last step. Next, conclusion. The initial exploration of the dataset revealed that the ratio of the infected iPhone devices was more than 60%. Then we analyzed the time and traffic volume characteristics of Xcode Ghost related HTTP request. The results indicated that these infected applications usually send user related information to specific web servers when a user used the infected application, that these requests were similar with usual HTTP requests, which increased the difficulty to distinguish them from usual HTTP requests. So once have a look of all the slides. In the first slide is a topic name analysis of malware application based on massive network traffic. This is an introduction which I have said before, said about Xcode Ghost, which is a new iOS malware. This is about how to analyze the Xcode Ghost. Firstly, identification of the in detail how source code, and next about scanning the source code. Next, related information. Here we have an important feature, that is the first smartphone malware was discovered in June, that is Cabrin Symphoban OS, which is propagated via Bluetooth. This is about a network architecture with TMS, and it's about the figure 1 and ratio of the infected device. Here is the how to know whether the device is infected or not. The condition is given, and here is the ratio of infected devices and model of infected devices, 2 graphs. And here is the dynamics of Xcode Ghost servers, and it's the access time characteristic. Application identification algorithm, which is consists of 5 steps. Once again repeating: extracting the fingerprints, getting web knowledge, data fusion, application identification, checking manually. This is on conclusion, which is saying that we analyzed the time and traffic volume characteristics of Xcode Ghost related HTTP requests, and these are results. And thank you, friends. I hope my lecture is useful for you, and thanks for watching. Thank you.